Hello viewers, welcome to my channel. We are still continuing the tutorial on logarithmic function. Here we want to play around with some of the properties we have learned so far. But before then, let's define what a common logarithm stands for. When we talk of a common logarithm, we are referring to a logarithm with the base 10. So if in case you have log 8 given to you, the base has not been mentioned. This simply means that this is the logarithm of 8 base what? 10. So any logarithm that the base is silent, then it means it is already in base 10. That is why you can see your calculator is having a log written on it with no base. So all calculations you use your calculator to do without the change of base is in base 10. All right. Then the natural logarithm, that's the ln. Some call it the ln. The ln is a logarithm with the base what? E. So if you see ln is the same as what? Logarithm with the base what? E. Talk less of what the number will be. So if in case I have a ln or ln e, then it means that this is going to be log e the base what? E. You remember our property we did that if you have a logarithm that has the base as what? The argument, your answer is going to be what? 1. That is why in some calculations you see ln e being equals to what? 1. So whenever you are calculating and you try to put in a value of 1, you can still introduce what? Ln what? E. So any of these aspects you see, this is defining common logarithm and this is defining what? Natural logarithm. So now let's put them together with what we have done in the previous episode to provide answer to this question. Log 10, the base is silent. So what do you think is going to be? It means the log 10 base 10. Then the idea we have here, a logarithm of the argument and the base being the same equals 1. Simply put, this is going to be what? 1. So log 10 is 1. All right. Then we have the logarithm of 49 base 7. What did we do? In the previous episode, we said that we can equate this our logarithm to become a function in the sense that I have the logarithm of 49 base 7 equals y. So right away, we can let this be the base, taking this as the exponent equals to 49. So under indices, if I have this, I can break this to base 7, meaning 7 times 7 giving 49. 7 times 7 means 7 exponent 2. So since the base are the same, we take the exponent. So it means if y is 2, then the whole of this simply means what? 2. When we get into the laws, we can also use the law to get the answer of this. But when we get there, I will explain that concept also. Then we are having logarithm of 1. The base is also silent. What do you think it will be? It means log 1 base 10. Following the same approach we did here, it could be the logarithm of 1 base 10 equals what? X. So now 10 exponent x equals what? 1. How can we get 1 when we are having a power? So this could also be written in the form 10 exponent x equals to 10 exponent 0. You know 10 exponent 0 is 1. So since 10 and 10 are the same, x must be equals to what? 0. So if x is 0, then it means log 1 is also what? 0. Right? Good. Then I believe here we are on natural log. Ln e exponent what? 3. What is it going to be? If you want to write this back into the logarithm aspect, you'll be writing ln e exponent 3 as what? Logarithm to the base e. That's the meaning of ln. Then the argument will come e exponent what? 3. Remember all we are doing so far. If the argument and that of the base are the same, we go for the power. So this, the whole of them become what? 1. So the answer is going for the power. So this is simply what? 3. So lim e exponent 3, we take the exponent, leaving everything else. Here could also be solved in the example we did for number 2. And even number 3 and number 1, we can use the same approach. So I'll be leaving this for you to provide answers for in the comment section if you know what this will stand for. But I'll go for number 6, which is also one of the properties we talked about. So this here could also be taken as 5, the log of 2 base 5. We can let all this be equals to what? Y. Then, here, the base, take this. We are seeing that this. So the logarithm of base 5, take this as a number equals to the exponent log 2 base 5. Log base 5, log base 5. They will cancel, meaning y equals to 2. So if y is 2, it means the whole of this is equals to 2. Simply put, when you see an exponent with a logarithm as if you see an indices with a logarithm as an exponent, check whether the base of the logarithm is the same as what? The base of the indices. If they are, then go for the argument of the logarithm as your answer. I believe this concept is clear, and the common logarithm and natural logarithm. Good. Come back to this space for the laws of logarithm in the next episode. Share the video, like, comment, and subscribe if you are new. Bye-bye.